Dissipating energy. The kinds of problems that are best solved using the law of conservation of energy are those in which an object moves from one place to another under the action of well-defined forces. The law of conservation of energy will simplify problem solving because energy is a scalar quantity while forces is a vector quantity. That means forces will require more effort, more information, and more calculations to solve the same problem. Drawing a diagram is still essential for deciding which forces do work on the object. Remember, if an object has any height, it has gravitational potential energy. And if there are any other forms of energy, use conservation of energy to solve your problem. If only conservative interactions occur in the system and there are no external forces, then total mechanical energy is constant. If there are non-conservative interactions or external forces doing work, you must use the more general statement of energy conservation. Interactions can be described by forces. It's very important to distinguish between internal and external forces. For a closed system, you would use this form of the equation. TMEI equals TMEF. Kinetic energy, gravitational potential energy, and elastic potential energy in the beginning has to equal all of those same energies in the end because no energy is leaving the system. If energy is dissipated due to kinetic friction, static friction doesn't dissipate energy, then you would use this form of the equation in which you include the term for work done by a non-conservative force in the left side, and we're subtracting because energy is leaving the system. Meanwhile, if energy is added from some external force, then we would have the work done by a non-conservative force on the right-hand side of the equation. This one's used pretty rarely.